In this video, we're going to go over our Module 9 study guide on expressions. This is VL-936. Let's go ahead and get started. So we are going to select all that are equivalent to 2 to the 6th. That means it's not 2 times 6. It's not 26. It is 2 times 2 times 2 times 2 times 2 times 2. It's 2 6 times. Now, what happens when you multiply 2 by itself 6 times? Well, let's see. There are a couple ways you can do this. I can go like 2 times 2, which gets me 4, and times 2, that gets me 8. Or some people would actually like to do this. Well, that's 4, and that's 4, and that's also 4, so we can multiply those, and that gets me 16, and then 16 times 4 is what is that? 64. So that's one way you could have done it. You could have also said 2 times 2, which is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So we're looking for any of these, we're looking to see if any of these expressions are equivalent to 64 if you simplified them. That's one way of doing it. So 2 to the 3rd times 2 to the 2nd. One way of looking at that, just by the way, is 2 to the 5th power, because you're multiplying 2 by itself 5 times, right? So that's definitely not 2 to the 6th. But if you wanted to work it out, 2 to the 3rd is 2 times 2 times 2, which is 8. 2 to the 2nd is 4. Does 8 times 4 equal 64? It does not, so no. B, 2 to the 2nd times 2 to the 2nd times 2 to the 2nd. Well, 2 to the 2nd is 4, and that's also 4, and that's also 4, and 4 times 4 times 4 does equal 64. And if you remember, we had 4 times 4 times 4 over there, so yes, that does equal 64. 26, 2 times 6, 26, no. This is 2 times itself 6 times. That is correct. 4 times 4 times 4, does that work? Yes, it worked up here. It worked over here. It will work for us. 2 times 6. No, 2 times 6 is 12. 64? Yes, 64 is one of the answers we got. 4 times 2 to the 4th. What is 2 to the 4th? 2 to the 4th is, gosh, times 2, which is 4. Times 2 again, which is 8. And times 2 again, which gets us 16. Does 16 times 4 get us 64? It does. So this does work. Does 12 work? It does not. Does 6 times 6 work? It does not. So our answers are B, D, E, G, and H. Let's just take a look. Expressions that are equivalent to 5 to the 3rd power. 5 to the 3rd power is just 5 times 5 times 5. And that is that's 25. And sorry, that's messy. 5 times 5 is 25, and if you multiply that by 5, you get 125. So which of these are equivalent to 125? Well, it's not 53. 25 times 5, yes it does, because it was equivalent over here. Yes, this is. 5 to 3 times 3, no, that's 15. 125, yes. 5 times 5 times 5, yes, that is what 5 to the 3rd is. 15, no. 5 to the 2nd times 5, yeah, that is 25 times 5. And 3 times 3, 3 5 times, no. No, no, no. This is 5 3 times, not 3 5 times. Let's look at number 3. They want to find the value of 7 to the 3rd power. That is 7 times 7 times 7. But when they want you to find the value, they want you to simplify, basically. That's 49. And when you multiply 49 times 7, I don't know what that is off the top of my head. Ooh, I figured it out. It is 343. So finding the value is basically simplifying it. 8 to the 0 power. Find the value of 8 to the 0 power. Anything to the 0 power is 1. Yeah, so if you had 15 to the 0 power, that equals 1. Or 9 to the 0 power is 1. Or 1 to the 0 power is also 1. Anything raised to the 0 power is 1. Number 5, write this expression in exponential form. Well, that is just 2 times itself 6 times, so that's 2 to the 6th. Number 6, write this in exponential form. That is 12 multiplied by itself 3 times. That means 12 to the 3rd power. Let's look at number 7. We are doing simplifying the expression all the way down to a single number. This is basically PEMDAS. Parentheses, exponents, multiplication, division, which are on the same level. Finally, addition, subtraction. What this means is you don't always multiply before you divide. Sometimes you'll divide first, and sometimes you'll subtract before you'll add. It just kind of depends on if you have multiplication and division, you'll go left to right. So number 7 gives us a perfect illustration of that. There's no parentheses, no exponents, but we do have both division and we have multiplication. So even though we call it PEMDAS and it's like, oh, multiplication is before division. No, multiplication is not before division. They're both on the same level. So if they're both on the same level, what should you do first? Well, you approach it like you would read a book. You go left to right. So the one on the left goes first. All right. So 12 divided by 4 goes first. 12 divided by 4, which gets us 3. And now we bring everything else down, times 7 plus 4, 22 minus. All right, now I still have some multiplication. Deal with that. That is 21. Bring down the plus, bring down the 4, bring down the minus, bring down the 22. Is there a faster way of doing this? Yes, there is. You don't have to write everything down all the time, but we want you to get used to this and get comfortable with this because once you're good at this, you can start using shortcuts. But because we're learning it, we're not using shortcuts. 22 minus 21. Remember, if you have subtraction and addition or addition and subtraction, you go left to right because they're both on the same level. So we're going to subtract first. That's 1. Bring down the plus, the 4, and that equals 5. Let's try number 8. Number 8 is an interesting one. We've got a top section and a bottom section. How do we work this out? Well, you deal both the top and bottom sections separately. So the top is 12 times 4, because that dot means times. And 12 times 4 is 48. All right, let's do the bottom now. The bottom is 2 to the 3rd power. What is 2 to the 3rd power? It's not 6. It is 2 times 2 times 2, which is 8. All right, now let's put it together. The top was 48. The bottom was 8. Now you can look at this like a fraction and say, okay, well, I got to simplify the fraction. It's an improper fraction, so basically you're dividing. And guess what? 48 divided by 8 does divide evenly. 48 divided by 8 is 6. So that's our final answer, because remember, this is a fraction bar or a division bar. You just divide, and anything you have left over, you can divide and have a decimal answer or a fraction answer. In this case, we have a whole number, which is nice. Let's look at 9. Simplify. We do have parentheses this time, and inside our parentheses, we have an exponent and subtraction. So what do you do first? Well, you do PEMDAS inside the parentheses. So inside the parentheses, there's no other parentheses, so we do exponents. And that equals 4 to the 2nd is not 8. It is 4 times 4, which is 16. 16 minus 5, bring down the parentheses, the times, the 3, the plus, the 5, bringing everything down. Still deal with inside the parentheses, 16 minus 5, which gets us 11. Going to bring down the times, the 3, the plus, the 5. And some people will say, well, you don't have to bring down the parentheses. Yeah, you technically don't, because there's nothing left inside to do. It's up to you whether you want to, but if there is a number right next to the parentheses, like 11, and there's parentheses and like a 2, what that would mean is multiplication. If there's like 11 parentheses and an exponent, that means you need to do the exponent, like apply that to the inside. But there's nothing inside the parentheses left, so I can basically and there's no number next to it, so I can basically get rid of it. Anyways, let's not worry about that. We have 11, 5 plus 11 times 3. Multiplication beats addition. That's 33. Bring down the plus, the 5, and 5 plus 33 is 38. That is our final answer. This one, if yours says 18, it was because it was a typo. It should say 28. Otherwise, you get like negative numbers, which we don't want to deal with. So we have parentheses right here. Inside this parentheses, we have addition and division. And guess what? Division beats addition. So 18 divided by 2 is 9. Let's bring everything else down. 4 plus 9, parentheses, times 2 minus 28. Now we have 4 plus 9, which is 13, I believe. Bring down everything else. There's nothing to do in the parentheses, so basically I start looking for exponents, multiplication, division, subtraction. Here's some multiplication right here. 26. Bring everything else down, 28, and minus 28 minus 26 is 2. If you had 18 minus 26, well, you know, you end up with some negative number, which is not nice, but, you know. Let's move on. We've got a top and bottom here as well. So I'm going to deal with the top first. I'm going to rewrite the whole thing. 12 plus 72 divided by 9 times 2 minus 4. All right, no parentheses, no exponents, but we do have division and multiplication, so we go left to right. Saying 2 divided by 9 is 8 times 2 minus 4, 12 plus. All right, got to deal with that multiplication first. That's 16 minus 4, 12 plus. All right, and now we go left to right because addition and subtraction are on the same level. 12 plus 16, that is 28 minus 4, that is 24. We are not done here. Don't circle that because we still have to deal with the bottom. And the bottom was pretty simple. It was just 2 times 3. And yes, I know you could have just put like a divided by 6 over there. I get it. But I'm just showing you everything. So the bottom is 6. So our problem that's left over is 24 over 6, or 24 divided by 6. Simplify that. We do division. And 6 does go into 24 evenly. It goes in 4 times. Let's try number 12. Find the prime factorization of 24. Prime factorization means I need to factor the numbers out. One of the ways I can do that is a factor tree. So I ask myself, what numbers multiply to get us 24? Well, how about 12 and 2? 12 times 2 equals 24. 2 is a prime number, so I'm going to circle that. And you know, the only way you can break down 2 is like 2 and 1, which if you're breaking it down by 1, you're done. It's a prime number. 12 is the same thing as 6 times 2, or you could say 3 times 4. It doesn't really matter which way you go. You're still going to get the same answer at the end. 3 is a prime number, so I'm going to circle that. And 4 is just 2 times 2. And now I look at my prime factors. I have 3 2's. And a 3, so I could say it's 2 times 2, well, let's be lazy, 2 times 2 times 2 times 3, I want to keep it in order, but 2 times 2 times 2, another way you can rewrite this, which you should, is 2 times itself 3 times is 2 to the third times 3, so that is our answer, 2 to the third times 3. It's a good idea to write your answers in order, or your numbers in order from least to greatest, so that's why I put the 2 first and the 3 afterward, but is 3 times 2 to the third the same thing? Yeah, sure. By the way, if you had done it this way, let's do a quickie. If you had said, oh, how about 12 times 2, when then this is like 2 times 6, and then this is 3 times 2, you still would have gotten the same answer, which is you got a 2, 3 2's, and a 3. So prime factorization is kind of fun. You can do it in lots of different ways. Let's do 63. Prime factorization. It's divisible by 3. Let's see, 3 goes into 60 20 times, and 3, that's 21. You could have also said 7 times 9, I believe. 7 times 9 also would have worked. So 3 and 21. 3 is prime. 21 is 7 times 3. And both 3 and 7 are prime, so it's basically 3. I have another 3 and I have another 7, so that's 3 2 times, and then 7 once. So 3 to the second times 7. Finally, 100. I know this one. That's 10 times 10. Neither of those are prime, so break them down. That's 5 times 2, and both 5 and 2 are prime. And this is also 5 and 2, and both of those are prime as well. So I have 2 2's, and I have 2 5's. What is that expression written out as? It's 2 2 times 5 2 times. A lot of times people then say like, oh, am I supposed to just like multiply this out again? No, this is your answer. This is the prime factorization of 100. If you multiplied it out again, guess what? You would get 100, which is, you know, which kind of makes sense. Anyways, that's it for the study guide. Go ahead and try some other problems on your own.